Hello, everybody. Welcome to All Your Containers Are Belong to Us. Right now, we have James Condon going to be giving us a nice presentation on containers. So this is a third of 3 consecutive containers. So a lot of you have gotten like container after container after container. Well, this is going to be the last one for now. So take it away.
All right. Thanks, everyone, for coming to my talk. Today, we're going to be talking about major Kubernetes components that have been exposed to the internet. So as far as an agenda goes, I'll give you a little bit of background on myself. We'll do a quick overview of Kubernetes because I know a lot of people here are pretty familiar with it. And then we're going to talk about the infamous Kubernetes Dashboard, the API server, and then the data store etcd. So specifically, I'll give you a little bit of an overview of what they are, and then I'm going to follow up with some demos of how we can find them attached to the internet. Then we're going to go through some of our research findings on that. And then we'll wrap up with security recommendations on how to harden them. So right now I'm Director of Research at Lacework. Lacework is a startup out of Mountain View. We do cloud security, everything from config and compliance auditing to anomaly detection, container, and Kubernetes security. I actually got my start in the Air Force Office of Special Investigations. And for those of you who don't know, OSI is kind of like the FBI of the Air Force. When I was there, I investigated network breaches and produced threat intelligence. Following that, I went on to Mandiant, where I was a network traffic analyst, supporting incident response and managed services. This was back around the time of the APT1 report. Then following that, I went to a company called ProtectWise, and there I built out their security research team. So my background is primarily in network forensics, incident response, threat intelligence, and recently I kind of made the move into cloud security, so focusing on container and orchestrator security, as well as Linux malware, and then cloud provider security. So if you're completely new to orchestrators in general, you're probably wondering, why do we need an orchestrator? Well, the reason is we've seen a big shift from large monolithic applications to microservices and containers. Now, as you start to scale up those microservices and containers, you start running into some management issues. It becomes difficult to do things like networking and scheduling. Now, Kubernetes is the most popular orchestrator out there right now. And if you're completely unfamiliar with Kubernetes, or you've never seen this video, the first place to start is the Illustrated Children's Guide to Kubernetes. This is a 10-minute YouTube video. It's very entertaining, and it starts off where a daughter asks her father, hey, Dad, what's Kubernetes? And he goes into this technical explanation and ends up just flying right over her head. So he tells it like a children's story where he uses this character here, this giraffe. His name's Fippy, and he's a PHP app. And he starts out living in a hosting provider environment where he's sharing the space with a bunch of these other unknown apps. And then Whale comes along, and that's Docker, saves him and puts him in a container, but over time he starts feeling isolated, so a boat comes along with an owl, and that owl is Kubernetes, and Kubernetes puts Fippy into a pod aboard the boat. And then from there, they kind of describe all the features of Kubernetes, everything from namespaces to volumes for storage to replication to service discovery. The other important thing to note is there's a lot of security features with Kubernetes, and really the big part is understanding what those are and what the defaults are set to if you're managing a cluster. But the main reason we're talking about Kubernetes is really hot right now. So I think it was a week or two ago I saw a tweet, and it was a graph, and this graph showed the number of times that the word Kubernetes came up in Hacker News job descriptions. And in 2016, it was kind of flatlined, and then 2019, you see this exponential increase. So it's definitely taking off. It's one of the fastest moving open source projects out there right now. So before we get into the research and the demos, I have a few disclaimers. First and foremost, no containers were harmed during the making of this presentation. And so what I mean by that is when we do research, we use things like Census and Showdown, and we survey for these different components. Now, when we discover them, we just kind of see what's there at that first layer. and then we survey those results. We don't actually go into people's clusters and start manipulating them. We don't kill off pods or do anything like that or download secrets. So the main reason I'm sharing this research with you, and specifically how you can do this type of research too, is really to promote awareness around exposure and also enhance security for your own clusters that you may be running. The other important thing to note is a lot of these kind of recommendations are really geared towards people who are administering their own clusters. If you're using a managed service like Google, Kubernetes Engine, things like that, a lot of times these are taken care of for you, but you still need to know what they are and be aware of them as well. Okay, so the Kubernetes Dashboard, this is a web-based cluster management UI. So you can use it for a lot of different things. You can use it for monitoring the state of your cluster. You can use it for viewing deployments. You can start new deployments. You can add pods. There's a lot you can do depending on the user or service account that you're using and the privileges that it has. Now, it's important to note that after Kubernetes 7, the dashboard has a default service account, and that default service account privileges have been lowered quite considerably since there's a lot of risk in using these dashboards. However, you need to use RBAC to make sure that those privileges are actually enforced. But one of the main reasons that we're talking about this is recently in the news, we've heard a lot about instances of unsecured specifically Aviva, Gemalto, Tesla was probably the biggest one in the news, and Weight Watchers. And one of the things that all four of these had in common is they all had credentials to the cloud provider within these accounts. And 3 out of 4 of them had been used for cryptojacking. So what we're going to do next is I'm going to give you a demo. This is one way that we can discover dashboards. And in this demo, we're using Census. Has anyone here used Census before? Okay, I see a couple hands. Now, has anyone here used Showdown before? Okay, so Census is pretty similar to Showdown. In essence, what it does is it crawls the internet and it looks for default services on their default ports. It makes queries to those, and then it pulls back that data, that information in the response to the queries. And then it goes ahead and it indexes this so you can use their engine to search through it. One of the things I really like about Census is there's a lot of breadth in the amount of attributes you can search. For example, you can do a very common string, but then say, okay, I only want to see this on port 443, HTTPS, status codes, things like that. The other thing is they refresh their crawling at a really high rate, so I've had really good luck with any of the findings I have still being live when I check them out. So if we back up one slide, we need to find these dashboards, we need to find something to kind of key off of, so we're looking for something unique. And if we look at the index page of a Kubernetes dashboard, ironically, a pretty unique HTML tag, we see Kubernetes Dashboard. So in our demo, what we're going to do is we're going to search that dashboard, look at the search results, and kind of follow it through to see what we get. So here I'm just typing in Kubernetes Dashboard. This gives us a list of results. On the left, you can see things like the associated ASNs, ports and protocols that are open, and then we drill into a specific one, and then we can actually go to where that page is being served. And so in this instance, this pops us right into a dashboard. The interesting thing here in this example is normally when you deploy the dashboard, when you first go to it, you get this prompt, and it's going to ask you either for a kubeconfig file or a token to authenticate with. And then you have the option to skip, which puts you in the default service account. So what we saw is that's pretty common in our findings, but we also saw sometimes that skip would be disabled, forcing the authentication. And then in other instances, it was completely wide open like this. So if you were actually to scroll up and down, and we blurred things out in this demo to protect the innocent, but what you can see is all the pods that are running. You can view secrets and the namespaces that you're looking at. A lot of sensitive information. So as far as our findings, this was pretty recent in February. Found about 500 different dashboards, with AWS being one of the most popular places to host them. Something important to note here is that this was on ports 80.443 and 80.80. And the reason that I bring this up is when you use something like Census, it's going to look for standard ports. And when you deploy a dashboard, you can deploy it on whatever port you want. And a lot of times you might be deploying it on an unusual port. And so this number could be a lot larger. We haven't actually gone through and tried to do any crawling on less common ports. The other thing to think about here is that 500, it could be, anything from people's, small deployments, test clusters, things like that. But it's possible there might be some more sensitive clusters within that. So that's something that we're continually researching and looking into. As far as recommendations, the biggest one is don't use it. If you can get away with not using it, this is something that really introduces a lot more risk than you need. But if you do, make sure that you have RBAC enabled so that service account, if discovered, has lower privileges. And then resist the temptation to maybe overprivilege that service account. Think about using other users or different service accounts to actually do any sort of your cluster administration. And then the biggest piece here is avoiding internet access. So you don't want this to show up on Showdown and Census. You don't want researchers finding it and blogging about it in the news. So put things, if you have to access it via the internet, with like VPN, Bastion hosts, things like that. So the next thing we're going to talk about is the API server. So the API server is really the heart and soul of Kubernetes. Handling all the communications to the different endpoints. It's implemented with the REST API, so it's very easy to use. And the important thing is it handles authentication and authorization. Now, something to note in a default deployment of this API server is it actually serves on two different ports, what they call the secure port and the insecure port. And the secure port is your normal API server as you know it, but the unsecure port is actually just an HTTP endpoint. And that ends up bypassing all the authentication and authorization. So it's really important that this guy isn't exposed. The other thing is we had that major CVE in December that broke the internet for a couple of days. This is important to note that if you haven't upgraded, then anonymous users discovering your API servers could potentially make elevated requests to some of your aggregate servers like metrics and service catalog and things like that. So in this demo, for as far as like a search term that we want to use, looking for the API server, one of the things that works really well is using Kubernetes Master. And the reason for that is in your SSL certificate, that's a very common name that you would see in there. And the other thing is if someone has basic authentication enabled, if you go to that endpoint and then you do not authenticate properly, you get a 401 response. You'll actually see in those HTTP response headers a www authenticate with the keyword Kubernetes Master. So in this one, I have the developer console up just so at the end you can see what that response header looks like to confirm that we're looking at an API server. Something interesting to note is you do want to do this in quotes, otherwise they'll search for those terms separately. So we search Kubernetes Master. Here we get a lot more results than we were seeing with our dashboard. We'll go ahead and click on one of those. And then follow that through. Now, when we visit this in Chrome, we'll get a warning about the certificate. When we go past this, we get this password prompt. Go ahead and cancel out of that, and we end up getting our unauthorized 401 response. And then what you can see there, and this is kind of cool that we're in the IMAX because on no other screen would you actually be able to read that. But what you see is there's the status code 401 and then that www authenticate basic realm Kubernetes Master. So as far as our findings, see quite a few of these. So from doing some recent searches in January and February, we're seeing about a little over 21,000. The vast majority of these belonging to AWS with a very small amount in GCP and Azure. One thing to point out is in 2018, Lacework did a research survey where we were looking at all the different orchestrators, including Mesos Marathon, RedHat OpenShift, and Docker Swarm. And kind of the combined total of management nodes that were accessible to the internet was about 21,000. So basically what we're seeing is in this time, a lot more of these being discovered. Something that I also found pretty interesting is the SSL certificate common names that we see on these. Like I was saying before, Kubernetes Master is one of the most popular, and then you see things like System API Server, API Server. So just something to be aware of. So probably the most interesting finding of all, and this is truly a all your containers are belong to us scenario, is we found over 800 of the insecure port being open. Now, I didn't include this in the demo because there's a lot of sensitive information there, and we're still kind of combing through it and seeing what some of the results are. But it's important to note that with any of these API servers, you could just locally use kube control, point that at that server, and then you have cluster admin level access to it. So we hear a lot about the defaults of Kubernetes, and I think a lot of times we say, well, no one would ever do that. But once we start putting numbers behind it, we see that this ends up happening. So as far as recommendations, same with the dashboard. You really want to restrict that network access. Even though your secure port is going to handle authentication and authorization, you still don't want to leave a footprint out there. You don't want people to maybe use that for more information in a reconnaissance stage. So restricting access with VPNs. The other really big thing is make sure you disable that insecure port. If you're bootstrapping this yourself, it's really important that no one can access that. Enabling RBAC, what's good with authorization if you aren't using it. And then there's a lot of new advanced authentication options that are being offered through some of the different providers that can give you another layer of depth there. And then upgrade. So when that big CVE came out in December, one of the important things there is there's a lot of people that were kind of in this position where if they were to upgrade, it would break a lot of things. So always being in that position where you can upgrade because there's always going to be more CVEs that come out. Okay, so etcd. etcd is an interesting one. It's the distributed key value data store used by Kubernetes. It maintains cluster state and secrets. By default, there's no authentication on this, and there's also no encryption by default. And so any of the secrets that are stored from Kubernetes are actually just base64 encoded. And then it has some very, very nice and easy to use REST and gRPC APIs. And so the joke I kind of make about this is etcd is like the Luke Hemsworth of unsecured databases on the internet. Every day you hear people talking about new researcher found Elasticsearch or MongoDB with a bunch of sensitive information, but you never really hear much about etcd. I think last year there was one blog post kind of talking about this, but what you're going to see here in the demo is that this is actually a problem as well. Okay, so for this one we're going to use Showdown, and there's a couple ways we can discover etcd clusters. One is looking for the default port, which is 2379. But Showdown also can recognize when it sees an etcd cluster and tag it as such. So what we'll actually do is use that tag to do our search results. And then at the end of the demo, I'll show you just like a really quick and dirty curl command that can recursively list the key value pairs that are in your data store. So here we're searching product:etcd. And from the search, we can see about 2,400 when we do this. One of the interesting things is most of these are located in China. And then here, this is just a very simple curl command that's piped to jQuery for formatting. And that's really all it takes. So for these etcd clusters that you see out there, you could actually run these and dump out what's inside of them. One thing you can do from a research perspective, instead of actually doing a GET request and pulling that data down, is you can make a head request just to see that you get an OK response, knowing that they may be vulnerable to that. So as far as our etcd findings go, see about what we saw in there, about 2,400. See that kind of go up and down. I think the blog post I was talking about this last year was more around 2,200. And just because we found etcd, that doesn't necessarily mean that that's part of a Kubernetes cluster. You could use etcd for other things. But one of the things that Showdown does is it can pull down any names that have been assigned to the clusters. And when we come through that, we end up seeing that there's a lot of Kubernetes-related names, such as Kube Master, Kube Master etcd, K8s node, all kinds of things like that. So as far as recommendations, we talked previously a little bit about your network access. Well, in the case of etcd, using it in your Kubernetes cluster, it's really important that the API server is the only one that's talking to it, as you can see from that demo that we just showed. Some of the things that you can do to kind of enhance the security of that is you can use TLS for any of the peers in the cluster for their communication back and forth. etcd also does support certificate authentication, so you can use that for some defense in depth. And then there's a number of different third-party options that are coming out for encrypting the data at rest. So this is something really helpful to look into in the event of some sort of unauthorized access. Okay, so it's just some final thoughts on our research. And yes, this is a stock photo of Dave Franco. I was pretty excited to find that one. As you can see from the different numbers that we have up here, the amount of exposure is pretty large scale. We talk about defaults of Kubernetes, and again, we say do people actually do that? And now we kind of have some numbers to back that up. Something important to note here is that internet exposure is just one piece of the security puzzle when it comes to Kubernetes. There's a couple of talks earlier talking about container security, and when you're thinking about Kubernetes, you need to also be thinking about, okay, if a container in a pod gets compromised, what's the blast radius of that, and then how can attackers move further from there. The other really big thing about this is Kubernetes has a lot of security features, and a lot of the work, if you're administering your own cluster, is really finding out what those security features are and then how you can use them. And then probably even bigger is if you're using tools to bootstrap your cluster, if you're using micro K8s or kubeadmin and stuff like that, is really understanding what they set those defaults to. So what I went ahead and did is I uploaded my slides to the schedule, so you can actually pull this down. There's a bunch of different resources here that you can go through. And then I have my contact information here. You can follow us on Twitter for things related to container and orchestrator security, Linux malware, stuff like that. And now I'd just like to open up to any questions that anybody has.
Going once.
Got one up there.
How am I going to get this up there? Jesus. Excuse me. Where was it? Oh.
Thank you. For API server recommendations, you mentioned looking into advanced authentication options. Can you talk about some of those?
Yeah, so I'm not too familiar with a number of them. I know that Google Kubernetes Engine is supporting a few different ways, I think it's OpenID, things like that. But yeah, you can check out some more on that, I think, from their website if you're using Google Kubernetes Engine.
Any other questions? Take your pictures now, or they, as he said, they are attached to the schedule, so you can actually download them.
Yeah, the only thing that won't be in the PDF is the actual videos, but. you can always send me a message and I can talk about some more details around that. All right, cool.
Okay.
Well, thanks everyone for coming. Stop by after if you have any questions.